Hello everybody, today we're going to be taking a look at trapezoids, two different types, a regular trapezoid and an isosceles trapezoid, and also kites. So we're going to be looking at some other four-sided shapes that are not parallelograms like the ones we've been talking about. So let's imagine or picture what we think about when we think about a traditional kite, you know, the thing that flies in the sky on a string, windy days. Okay, so this is that same idea when it comes to the shape kite. So this is the picture that you should put in your notes, and then we're going to take a look at the properties as they relate to the angles, the sides, as well as the diagonals of this kite. The first property is that the angles will have one pair of opposite angles that are congruent. So only one pair of angles on this four-sided shape is going to be equal, and those two angles are going to be A here and C here, because it's like I could fold that kite in half and those two angles would line up right there. So one pair of opposite angles are congruent. B and D are not the same. D is a little bit shorter down here. Okay, that angle right here, not shorter, skinnier. Okay, that angle right there is going to be different than B because of the way the kite is shaped. Okay, just simply because he's a little bit longer there on the bottom. Also, when it comes to sides, we're going to have two pairs or two disjoint pairs of consecutive sides that are congruent. So there are some congruent sides here, but it's not opposite sides. It's BA and BC up there will be equal, as well as AD and CD will be equal on our kite. Let's talk about diagonals. The diagonals inside that kite will be perpendicular, okay? They will be perpendicular. They will make a 90-degree corner right there, four right angles. Think about how a kite is constructed. You have those support braces in there to make this kite shape, and then we tie some string on it, and we go for flying a kite on a windy day, okay? So diagonals are perpendicular. And also, one diagonal is a perpendicular bisector to the other. That means one diagonal will in fact be cut in half and one will not. The one that is cut in half, A to the middle there and C to the middle here, those will be two equal pieces. However, B up here and B all the way down to D, those will not be cut in half simply because of the way, again, the kite is shaped. So these are the kite properties. And one more, one diagonal bisects opposite angles. So B up here, oops, angle B up here will be bisected. There'll be two equal little angles up here at the top and on the bottom as well. Bisected here at the top and at the bottom. Not bisected on the sides over here. You can take a look at this angle at C. That angle has one skinny part and one part that's a little bit wider, so not bisected, not equal, okay? It's not cut in half. Again, kite properties. Let's talk about trapezoid. Trapezoid is another four-sided shape. Make sure that you put this one in your notes now. And again, we're going to look at all the different things that can happen with a trapezoid. And you see right there, diagonals I have listed, but we're not actually going to put anything there because there is nothing special so much about the regular traditional trapezoid's diagonals. Okay, so let's talk about sides. Sides are all going to be different lengths. Okay, not a single side is equal to another side. However, the bases, or what we call bases of a trapezoid, are going to be parallel. The base is obviously AD down here. He's going to be parallel to BC. Usually when people draw a trapezoid, they draw those parallel sides on the top and the bottom. These are called the bases, okay? AD, BC, those are the bases. The angles in a trapezoid will all be different. They will not have any congruent angles. Each lower base angle is supplementary to the upper base angle on the same side. So that means that we will have some angles that add up to make 180 degrees. So typically, none of the angles are the same, unless of course you have some 90-degree angles in there, but that's beside the point. Each lower base angle here is supplementary to the upper base angle on the same side. That means if I go up the side of that trapezoid, these two right here, while they will not be equal to each other, they will add up to make 180 degrees together. Angle A and angle B will add up to make 180 degrees. Okay, so we do have some angles that add up to 180, even though we may not have angles that are exactly equal. Oops, back. Make sure that you wrote down the diagonals, nothing unique, okay? Let's talk last but not least about isosceles trapezoid. Now with isosceles trapezoid, there's a few more things that happen. Because he's special. Isosceles, again, for triangles means you have two equal sides. Isosceles trapezoid, a similar thing is going to happen. We're going to have two equal sides. The sides that are equal are called the legs. So here, AB and CD are the congruent legs of our trapezoid. Okay, so it does have two equal sides there. Again, the bases will still be parallel because that's what makes it a trapezoid. Trapezoids have one pair of parallel sides. So the bases will be parallel again, and the legs now, because it's isosceles, will be congruent to each other. In a typical normal, I'm going to go back here, in a normal typical trapezoid, nothing special, notice that A to B on this guy and C to D, they were not congruent to each other. But now we do have those legs that are congruent. Okay, let's talk angles. Because we have an isosceles trapezoid now, we do have some congruent angles. The upper base angles will be congruent to each other. So B and C will be congruent, as well as angle A down here and angle D right here. They will also be congruent. The base angles are the angles that are right next to a base, or right on top of a base like this. The lower base angles are congruent, like I just wrote, A and D. And still, any pair of upper base is supplementary to a lower base angle. So again, still, we're talking about angle C and angle D right here. Adding together, they should still make 180 degrees. And that's because of the parallel lines in there, because those two angles would be consecutive interior angles. That trails back to what we talked about when we talked about parallel lines. Now, because it's isosceles again, diagonals, they are congruent as well. So B all the way to D, it's hard to draw that here. B all the way to D and A all the way to C, they are congruent. And you would see little congruent pieces in there as well. So be sure that you're noticing that when diagonals are congruent in those shapes, we can set things equal to each other in those pieces on the interior. Okay, one more thing we need to add in our notes after our shape properties. We have a special property that only applies to trapezoids, and it's the idea of a midsegment. So here's what a midsegment is. A midsegment of a trapezoid is a segment that connects the midpoints of the legs. So midpoint here, that'd be a midpoint of the side. See how these are marked with two congruent little slashes here? That means he's in the middle. 1 slash means this guy's in the middle. And if I connect them, that's called a midsegment. Okay, so we made a segment basically through the middle of the trapezoid by connecting the midpoints of the legs. Now what's cool about the midsegment is it's parallel to the bases. It's going to be also one of those sets of parallel lines. We just made him through the inside of the trapezoid. He will continue to be parallel to the bases. Next, the length is equal to half the sum of the bases. So half of what I get when I add base 1 plus base 2. Okay, that's what a midsegment is. When I add the bases together and I take half, the midsegment is going to equal that length. So that's the property. I wrote kind of a little formula right here if you want to use that. That's going to help us find the length of a midsegment through the middle of a trapezoid. So with that idea, let's go ahead and do an example. You don't have to write the words up there, but I might draw the picture in my notes. I have a nice little trapezoid here. Okay, here's our trapezoid. And notice we have a line through the middle. I know it's the middle because these are marked congruent over here as well. That is a midsegment. Now, if I was going to find the length of that, or I wanted to know how long that was, what would I do? Well, I would basically do that little formula. It said midsegment equals 1/2 of the base 1 plus base 2. So add the bases together and take half of it. So I'd have 1/2 base 1. It doesn't matter which one you put there, 6 or 18, because we're going to add them together anyway. And 6 plus 18 makes 24. What's half of 24? 12. So the midsegment is 12. So in here in our picture, we would know that that's 12 centimeters. That kind of makes sense. It needs to be halfway in between 6 and 18. It's like we're finding the average or something. When you add them together and divide by how many numbers you have, that's what we did. Okay, we added them together and we basically divided by 2. What do we do when we have algebra in there? I would get this one in my notes. Algebra is a little bit tough when you start throwing some letters on there. Okay, same trapezoid. E to F is x plus 5. DC plus AB, so adding the bases already, because DC is a base, AB is a base. When they've been added together, it equals this. We need to find out how far it is or how long it is from E to F. Well, let's think about what our midsegment formula says. Midsegment is 1/2 bases added together. 1/2, what are the bases added together? They gave us that. It's right here, 4x plus 6. What's the midsegment? Well, that's labeled with some variables and letters, or variables and expression as well. So we'll put x plus 5 on there, because that is the midsegment's label according to our picture. And now we solve this using our algebra skills. So this I'm just going to keep as x plus 5. I have 1/2 times 4x plus 6. I'll go ahead and distribute that 1/2. 2x plus 3. And then we go ahead and try to isolate the x. Subtracting 3. X equals 2. So we know what x is. Now can we find how far it is from E to F? Because it wasn't just find x, it was find out how far it is from E to F. If I plop that 2 right there, I would know that E to F is 2 plus 5, or 7. Okay? So using algebra, we can also solve some of these things if we think about that midsegment formula as something that's useful for us when we want to calculate missing pieces. Okay? So I want to thank you for taking good notes, and we'll continue to work on these shapes.